with this, we can now start with our session with some lead presentations, and also we would like to have discussion. And what I have assessed is that we are already running late for this session by half an hour. So we have 9 presentations. I would say that each presenter may take just 10 minutes each. Maximum 1 minute more for closing, and we would like to just advise you when 10 minutes are over so that you can conclude, so that we have few minutes at the end for final discussion, if possible. With this, I would like to now request our first lead speaker, who is again very eminent person, Dr. Farooq Elbaj. He had been the director of the Center for Remote Sensing at Boston University for a quite long period, 24 years. He established and directed the Center for Earth and Planetary Studies at the Smithsonian Institution. He served as science advisor to the late President of Egypt, Honorable Anwar Sadat, and presently he is serving on Advisory Council of the President LCC of Egypt. He is recipient of Egypt's Order of Merit. No one could be better to have here as key, lead speaker for this session, and he would be addressing us on use of satellite image, data and monitoring, and assisting food production in arid regions. So I request you, Dr. Farooq Elbaj, please take the floor. Dr. Farooq?
Professor Dr. Farooq isn't online yet.
I hope you are online.
He's not online yet. He hasn't joined yet. He has not come. Yes.
Maybe then we can switch over to the next presentation and wait for him. If he joins later, organizers can contact him, please.
Yes, it's okay.
In that point, then we have the next presentation by
Dr. Sheta.
Seta.
Yes.
Dr. A.S. Seta, former Chair Soils Department, Faculty of Agriculture, and SAMS University, Egypt. May I request you, Dr. Sheta, to address us on monitoring the spatiotemporal urbanization and its ecosystem responses in some central Nile Delta areas using remote sensing.
Okay. At beginning, I think I thank very much the organizer of this meeting, Dr. Biltagi and Dr. Abu Hadid, for the great opportunity to attend this and also to give informations with latest information related to what we need right now. My presentation concerning with monitoring spatiotemporal urbanization and the ecosystem responses in some Nile Delta areas using remote sensing data. This is very important concerning also the climate change, because when you change the climate, when you change the land use from agriculture to urban, it practically it change also the everything related to the soils. The introduction: historically, alluvial soils of the Nile Delta and the valley dominated by terrates, which is the suborder of vertisol, the most fertile soils in the world, and the fluvians suborder, which also belong to anti-soil order, where the main agricultural land use in Egypt and the production of food and fiber depends mainly on the limited irrigated alluvial soils. Also, the negative effect of urban encroachment over the valued fertile land will most probably denature part of the cultivated land, which in turn creates an informal demographic features over a deformed land pattern. And this is what we see right now in our old alluvial soils. Climate change is causing considerable impacts on Nile Delta agricultural lands. During the past 2 decades, some of the warmest temperature ever recorded, and many hundred hectares have decreased the productivity of the soils. And this is what we are going to deal with this right now. Thus, changes of vegetation cover are very significant, particularly since global warming may have influence on food security in the coming years. Many studies have been carried out in different situations in Egypt, i.e. in the Ministry of Agriculture and Land Reclamation, as well as the universities like Ain Shams University and Cairo University and Alexandria University as well. The Technical Committee for Sustainable Land Use have been established in 2007 from different scientific institutions within Agricultural Research Center. And this technical committee have studied this problem in the whole Egypt, as well as in some areas in Egypt. Some of these studies which carried out by this technical committee, what you are seeing right now, we have used the satellite image and GIS data to introduce the land use maps for the whole country in the Delta and Valley in 1984 and also in 2007, and we have it also in 2010 as well. So we recorded all what happened in the agricultural lands from 1984. And I have also to say that in 1984, we have updated the cadastral map of Egypt, scale 1 to 2500, to see to allocate exactly the urban areas in the agricultural land. At the same time, we use it with the satellite data to have complete coverage of the Delta and the Nile Valley, the different land use. We can see in this map right now, or satellite data, we can see the different use. All these dots, just villages or cities in the agricultural land. And also, you can see also the lakes and the fish farms, as well as the sandy dunes or the sandy areas close to the Mediterranean. And here is a Rosetta branch and the Dimyata branch. You can see because we have some changes recorded from our study in this area. If you look also in 2007, this is very detailed data, and we have done it using the satellite data and the field check as well. You can see increase in land reclamation area in the west sides and also in the east sides and also in the northern Sinai area. So this sorry. I don't know how to get back. Okay. So I would like to show you that the very important point that I would like to raise in this discussion, that land reclamation in Egypt is one of the focus point which increased the green land, the agricultural lands, and also this is one of the defense for land, the climate change, because as I am going to show you that there is big difference between the emission from the desert soils or desert land and the agricultural land. So we have these data. Also, the lakes, you can see that also it changed. And also the area, maybe you can see this right here, agricultural area in 1984, about 7.2 million faddan, and the faddan is almost about 4,200 square meter. The area in 2007 increased to about 8.5 million faddan. Despite that, the urban area also increased. Therefore, land reclamation covered or increased the agricultural land, as well as covered also the urbanization happened in these soils. So total agricultural land and the land reclamation areas in 1984 about 7.2 million, in 2007 about 8.9 million faddan, and the increase is about 1.7 or 1.75 million faddan during this period. And the last column here, you can see annually the change happened in the land. Urban area in 84, about 42,000 faddan. Increased in 2007 to about 1,000,003 faddan. And this increases very much. Annually about 25,000 faddan. And concerning also using the roads, the expansion in the roads and the other things, it's annually about 30,000 faddan per year, which is very much affecting the agricultural land in Egypt. Here is some example of how we deal with the satellite data in different governorates in Egypt, like البحيرة, الشرقية, الغربية, and the others. You can see that the expansion or the urbanization increased from 2010 to about 2014 years, too much. And we have recorded all these changes in the different governorates as well as in the different areas in the country. This is one of the districts in Munufiyya, which is a Westla district. You can see that this the difference between the colors, the dark color and the other color, as well as the yellow color. The yellow color represents the urban areas. You can see that this is not, you can easily say this is agricultural land. It's agricultural area mixed with the urban areas. And the increase is very much, and this is to show you that urban area, urbanization is a big problem facing agricultural land in Egypt.
Professor Shekar, 10 minutes over, please.
The objective, okay, the objective of my study, the main objective of this research were to investigate the urbanization land use in selected districts in the Nile Delta, Shibir al-Qom and Questa, and its effect on the land surface temperature and the other parameters using remote sensing and GIS technique. This is a selected area for study, Shibir al-Qom and Westla. And also we use data from different sources. Landsat satellite images were used for the year 2000, 2014, and 2021. Landsat thermal bands were used also as well. A standardized precipitation index, we calculated this. normalized difference vegetation index on the DVI also were calculated from the satellite data to show the changes in vegetation as well as in the cerebral band. And this is the methods used to end up with final maps and tables and data extracted from the monitoring of all these materials used. The results you can see at Shibin al-Kob area in the different years, the change in the agriculture as well as in the urban areas. We calculated also, as I said, NDVI spatiotemporal distribution of the Shibin al-Kob area, which shows the agriculture area and the other land uses different. You can see that.
Please. Dr. Sheto, please conclude.
Okay. This is the data for Shibin al-Kob as well as for Westla. And the different areas calculated. This is land surface temperature during 2022, both in both districts. You can see the effect of temperature on that. Also, temperature increase during Kazakh. You can see the increase. We tried here to calculate the temperature of the agricultural land and as well as in the two districts, as well as on the urban areas, and also the areas transferred from agriculture to urban, and you can see the increase in temperature. Conclusion, there was a significant fluctuation in the urban area. Average air temperature increased about 1.28. A massive loss of agricultural land occurs in Westland and Kaza. Urban sprawl affected significantly in increasing land temperature in Westland and Salhiya and Shibin al-Kob. The most important direction of a change is from irrigated agriculture into urban area bar, and I would say also in the previous one, causing what we call it heat island effect. You can see this in the map produced for distribution of temperature. Thank you very much.
Thank you very much, Dr. Shekhar. I hope you will bear with me because time is a constraint. Otherwise, we would love to hear you more. But you had definitely covered most of the findings in your earlier introductory part. Now we have the next presentation by Professor Atsushi Tsunekawa. Professor Tsunekawa is currently the professor of Arid Land Research Center, Tottori University, Japan. He has been head of Strategic Management Office of International Platform for Dryland Research and Education at Tottori University, and he is appointed as a Science and Technology correspondent from Japan to the Committee on Science and Technology of United Nations Convention to Combat Desertification. Professor Tsunekawa is also a member of the Executive Board of International Dryland Development Commission. So, Professor Tsunekawa, now we would like to hear from you on modeling hydrological responses to changes in land use, climate, and land management in contrasting agroecological environments towards climate smart, sustainable land management in Ethiopia. I would request you to kindly bear with us and limit your presentation within 12 minutes, please.
Professor Raj, Professor Tsunekawa is not online right now.
Oh, he is not there?
I'm here on behalf of him.
Okay.
I'm here on behalf of him.
Who? Pardon?
This is Dr. Molato, and he will present instead of Dr. Atsushi.
Yes.
Malatu is going to present on his behalf?
Yeah, Dr. Mulato.
Yes, Professor.
Okay, so are you going to make presentation?
Yes, yes.
Please go ahead.
Thank you, Professor Raj, for inviting me for this presentation. My name is Mulatu Leo. I am a visiting professor in the Ireland Research Center in Totor University. Can you see my slides?
Yes. Professor, please close presenter view.
What about now?
No. Can you choose display settings and duplicate slideshow?
What?
Choose duplicate slideshow.
Well, screen mode.
Yes, perfect. Thank you.
Now?
Yeah.
Now it's all right.
Okay. Sorry.
Please go ahead.
Okay. Thank you. My name is Mulatu Leo. Normally, I'm originally from Ethiopia. I am here as a visiting researcher in Ireland Research Center in Totor University. I'm presenting on behalf of Professor Association ICA on modeling hydrological response to changing land use, climate, land management in contrasting agroecological environment toward this climate smart SLM in Ethiopia. This project normally a part of a SATRI project under development of next generation sustainable land management framework to combat the desertification. The main aim of this project is just to develop sustainable land management framework for Ethiopia to feed its rising population at the same time improving soil erosion management. And the specific objective is just to reduce soil erosion, improve land productivity, rising income level of farmer, and the next generation SLM framework development. To begin with, land degradation due to soil erosion is a serious global environmental challenge, and this challenge is more severe in least developing countries such as in sub-Saharan Africa, like East Africa. The gross soil loss from this region reached up to 4 billion tons per year, and 50% of this is generated from Ethiopia, mainly from Upper Blue Nile Basin, also so-called Abai, and from the Ethiopian highlands. So this Upper Blue Nile Basin, one of the largest river basin found in Ethiopia, and one of the economic corridor for the country. And as you may know, Grand Renaissance Dam is constructing in this basin. So this basin is really affected by soil erosion, and it contributes 30% of the total soil erosion of the country. So what is really the main cause of this soil erosion? The first one is a long-term land cover change, especially due to the deforestation activity. That means forest degradation to cropland, degraded land, or grassland or bare land is the main cause for this soil erosion. A recent study by this researcher found that 60% of the area experiencing land cover change, mainly due to deforestation. And another study on the headwater of Upper Blue Nile Basin called Lake Tana, the vegetation cover dropped to 10% from 20% within 75 years. And this value rise to
Professor
Dr.
Mulatto.
Mulatto, the voice is not there. Your voice is not heard. Check.
what
check.
about now?
It's okay now.
So have you followed this presentation?
Yes,
The
of course,
introduction part?
of course.
Okay.
What about this?
Yeah. Okay.
Okay, the land cover is one of the major cause for this soil erosion, mainly due to deforestation. So Ethiopian highland, about 60% of Ethiopian highlands experiencing land cover change activities. So another recent study showed that the vegetation cover dropped to 10% from 20% due to the vegetation. I mean, due to the deforestation activity and expansion of agricultural areas. So this decreasing in vegetation cover reaches to 40% when an area is subjected to agricultural activity. The second cause is climate change. Based on our recent study, in Ethiopia, the mean annual temperature has increased by approximately 2 degrees centigrade over 120 years based on CRU dataset. This estimate is greater than by 0.5 degrees from the global estimates normally. And particularly in the upper Blue Nile Basin, the temperature also increased by 0.3 up to 0.5 degrees centigrade. But importantly, there is no any significance in terms of annual rainfall either in the upper Blue Nile Basin or in Ethiopia in general. The third cause is just poor soil water conservation practice. In Ethiopia, normally the soil water conservation practice has been institutionalized since the 1970s, and extensive efforts has been done since 2010 through government and non-governmental SLM initiatives and different physical, biophysical, and agronomic land management practice has been done in the country, especially due to community mobilization. These activities was done due to community mobilization. And there was also a remarkable coverage of SLM in the country, but the sustainability is still below 20%. So it needs like a comprehensive study, highly important in this area. And also it's important to see the impact of the
just second, Doctor, just second.
Hello?
الناس اللي في الكنترول روم الحس من فضلكم ما ينفعش كده.
Doctor, we're muting the Zoom participant who's making the noise.
Kindly mute your mic, please. Others, other than the speaker.
Okay.
So
go ahead, Raj. Yes. Thank you.
Comprehensive study highly crucial about the impact of soil water conservation practice, reducing runoff and sediment loss, along with land use and climate change. So in this study, we try to use empirical and also distributed hydrological model called soil and water assessment tool to assess the impact of land use, climate, and soil water conservation practice in the area. So we select three representative watersheds that represents different agroecological environment: the highland, the midland, and the lowland. And we try to measure the sediment, the runoff for different land use type for more than almost 80 years. And we have enough observed data to analyze the impact of SLM, different SLM technologies in these three different areas. And we purposely selected paired watershed. The one is untreated, another one is treated watershed. So the treated is Kasri, Kecha, Sahi, the Laguna, Akusti, and the Bakafa is untreated watershed. When you say untreated watershed without SLM. When you say treated, watershed with SLM practice. So the first task was we explored land use land cover change for over 35 years, and we tried to investigate the driver and implication of this land use land cover change over the three different agroecological environment. We used high resolution satellite images for the period of 1982, 2006, and 2017. And we found that in the three agroecological environment, the natural vegetation shows a remarkable decreasing trend, while the cultivated land shows an increasing trend in the three agroecological environments. But importantly, in the highland area, Buda shows increasing of plantation. This is mainly due to the introduction of acacia decurrence for rehabilitation of degraded hillside areas in the highland environment. We also try to develop a relationship with population growth with vegetation cover. When it's a vegetation cover, natural vegetation cover, and plantation like grassland, bushland, and forestland. So we try to see the relationship between the cultivated land trend and the vegetation cover with the population growth. So as we see in the highland, in the border, the vegetation shows a decreasing trend from 1998 to 2005, but after 2005 shows a progressive increasing trend against the cultivated land. And in Dibati, that means in the lowland area, the vegetation cover is still under a decreasing trend, and the cultivated land is still under an increasing trend. Coming to the midland area, the vegetation cover shows a decreasing trend in 2005, and it's almost stable between 2005 and 2017. Also, the cultivated land shows an increasing trend up to 2005, 2006, but between 2006 and 2017, the change is almost stable. So we can say that the highland is under reforestation status, the lowland is under deforestation status, but the midland is under stable condition. And the second activity was we tried to see the hydrological response to land use, land cover change, and climate variability in this contrasting agroecological environment. We try to analyze the single and combined effect of land use, land cover change, and climate variability on long-term surface runoff and evapotranspiration. We used normally
please.
Okay, we try to use empirical models for this, and the change in land use increase the runoff in the three study watersheds, and also the change in land use decrease the evapotranspiration, but the climate change increases the evapotranspiration in the three different watersheds. And the third activity was we evaluate runoff and sediment response to soil water conservation by employing alternative modeling approach. We use a robust soil and water assessment tool in this watershed normally, and we followed two modeling approach, paired watershed modeling approach and single watershed modeling approach. The paired watershed approach just compares the runoff and the sediment for treated and untreated watershed. Single watershed approach, we try to compare before and after soil water conservation practice. So we try to analyze the single and combined impacts of land use, soil water conservation practice by developing 5 scenarios, and we calculate using this equation to see the impact, the single impact of each factors. And we found that using paired watershed approach, the surface runoff was decreased by 28 up to 36% when you compare to untreated watersheds. That means the soil water conservation practice decreases the surface runoff from 28 to 36%, and the soil water conservation practice decreases the sediment yield or the sediment loss from 51 to 68% using paired watershed approach. Coming to the single watershed approach, okay, the soil water conservation practice reduces by 40% and almost by 40% the sediment in the surface runoff. And the contribution of soil water conservation practice more than by 60% when you compare the impact of land use, land cover change and climate variability. As a summary, cultivated land showed a remarkable increasing trend in the land area and midland watershed between 2002 and 2017 at the expense of natural vegetation cover, whereas plantation market increased in the highland watershed. Land use, land cover change increased the surface runoff by ranging from 4% in the midland, 29% in the highland, and it increases also sediment yield by about 7%. And climate variability increased the evapotranspiration by 20%, by 20% in the midland to 57% in the highland, whereas it decreased the sediment yield by 6% in the midland area. So the soil water conservation practice in general decreases the runoff by 14 to 40%, and the sediment yield from 51 to 78%. So this study suggests that the change in land use and climate are expected to intensify in the future. So it is important to further understand the hydrological impact to devise appropriate climate smart SLM technology for water management, land and water management strategy. Thank you very much.
Thank you, Dr.
Sorry.
Yeah. We hope you will be with us. We will have some questions at the end. I hope you will be still with us till the end of the session. Thank you
I will be here. Yeah,
for
sure.
your quite comprehensive presentation and good work that you are doing. Next speaker is Dr. Toshichika Lijumi. He is the Principal Scientist, Institute of Agro-Environmental Sciences, National Agriculture and Food Research Organization called NARO, quite a famous institution in Japan. His research includes climate risk, assessment of global cropping system through crop modeling. And he is going to talk today on rising temperatures and increasing demand challenge wheat supply in Sudan. So Dr. Toshichika, please.
Professor Raj, Dr. Lizumi isn't online yet.
Okay.
We can move. Yeah.
Could you please switch on your video? Can the host tell whether he is linked to us online?
Professor Raj, Professor Lizumi isn't online, so can we proceed to Professor Adil Abu Naga?
Okay. Then we now are a little more comfortable. Our next speaker is none less than my good friend, Professor Adil M. Abul Naga. Dr. Abul Naga is eminent senior researcher, Animal Production Research Institute at ARC in Egypt. He had been former advisor to His Excellency the Minister of Agriculture and Land Reclamation. He had been senior advisor to Director General Dr. Adel Biltaji at ICARDA. That's where I had a lot of interaction with him. He had also been FAO representative to Pakistan and FAO contact to Afghanistan program. Dr. Abu Naga is very eminent animal expert working on drylands in Egypt. So we look forward to you to speak on national strategy and action plans for combating climate change impact.
Thank you, Mr. Chairman. I'm happy to see you even virtual. I'd like firstly to thank Professor Biltagi on a wonderful work on organizing this webinar, and also of allowing us to invite us to raise the voice of the livestock, which is usually not heard except on the table. So here we will move a little bit to the livestock. We are talking here about the national strategy and action plans for combating climate change impact on livestock, which had been carried on by the Livestock Research Council at the Academy of Science and Technology, which has been chaired by Mr. Mohsen Shukri and supported by our dear friend Subhi Salam. This is, I think, had been presented by so many colleagues, so it showed also that agriculture is contributing 24% to the greenhouse gas emission. And from that, 40% of the agriculture contribution is coming from rumen fermentation, besides 16% in the pasture. So that's what they accuse livestock, that it have a great contribution to the greenhouse emission. which is yeah, partly right, but partly can give us a room to move and mobilize things. One of the striking figures which I saw that in 1961 the gas emission was 2.7 million ton. In 2011 it come up to 5.3. So we can feel how much the climate change is affecting and coming so soon. This is just a figure to show you Egypt and the intensive solar radiation and the sea around everywhere. So it make it a very vulnerable spot to the climate, to the coming climate changes. Working with the desert, working with New Valley, it showed us how much the expected climate change is very intensive and very horrifying. So the national strategy of to combat climate change. Climate change. The national strategy of combating climate change on livestock have 4 axes. The first one is what we call it mitigation, is sustainable economic growth by setting plans for low gas emission and larger investment for renewable and alternative energy. This is mitigation. The second axis is the resilience and adaptation of climate change through sustainability of local national resources and ecosystem adaptation. The third axis is improving governance and management of climate change combat and establishment of early warning system. This is the governance. The fourth one, and I think one of the most important one, is developing infrastructure, research, technology transfer, and public awareness for combating climate change activity, the research and TT. So action plans included in the strategy include integrated practices to reduce gas emission from different agriculture sector. That is, we got to cooperate and coordinate that very well. Everybody doing some activity, but on his own. So we got to coordinate that to get really detectable results. Accurate and disciplined feeding system, utilizing new resource of feeds. There are a lot of work on that, and I think it got to get implementation. Reducing competition between foods and feeds. We are competing on the small piece of land which we are cultivated, so we got to solve that. Expanding cultivation of saline resistance fodder in marginal land. I think we hear some our colleagues share talking on this morning. The continued action plan, intelligent management of animal waste and the production of green energy. I think this is very important. Managing animal genetic resources, especially the utilization of heat-tolerant local breeds. Control transboundary diseases. Reduce red meat consumption per capita and increase fish consumption. Actually, a lot of people say how you are going to do that. It is done already because the prices of the red meat is increasing tremendously. Continuing action plan, improving technology and for value chain, animal husbandry, and welfare to reduce greenhouse gas emission. Enhance positive role of livestock and agro-ecosystem, reduce environmental footprint of livestock product supply chain, and smart housing system and care practicing. Before we close, I would like to mention something Mr. Ali Sabah mentioned it. The livestock, some of our activity within the Animal Production Research Institute on adaptation of local breeds. I think most of the speakers talk about mitigation, but actually we was focusing on the adaptation of local breeds. And Mr. Ali Sabah mentioned that the Barky sheep, which is the desert sheep breed, we digging about possible alleles and microsatellite related to the adaptation to hot condition and physical exercise, or exactly as we call it, grazing on poor pasture under hot condition. So that is, we found that a lot of alleles is related to that, and a very distinguished one. This result had been published already, and we found that some of it is related to the metabolic general mechanism in the body, but some of it are related to the pigmentation in the body itself, as most of our breeds have this pigmentation. This is very activity. Also, the local breeds in the New Valley, where we saw the very intensive solar radiation. So the temperature there is raising sometimes to up to 50 degrees centigrade, and very intensive solar radiation. But the breeds is surviving that and producing and reproducing. So this is also found. We are going the molecular analysis of the genomic analysis of this breeds to see what is its potentiality. Also, the breeds in Upper Egypt, sometimes in Aswan and the related thing Nuba, there is breeds which are local, very resistant to heat stress. Sinai also, we have a very black goats there. It's very resistant to the heat stress. So we are doing a lot of activity on adaptation and the better utilization of local breeds. I think we practicing the selection for the heat resistant animals on Bark sheep with Bedouin people on the Matruh, and we have a very encouraging and successful result. I was planning my presentation on 10 minutes, and I know we have very sharp and strict chairman, so I was so keen to keep it within 10 minutes. So I hope I succeed at least in not exceeding my time. Thank you, Mr. Baruda.
Thank you, Professor Abul Naga. We appreciate, and it is really very encouraging to note that there is a national strategy and action plan, particularly with regard to livestock in relation to climate change. And no doubt you're highlighting the importance of research is to be taken rather more seriously, in the sense that people are mentioning that from agriculture 50% of the methane emission is from livestock sector. But I think in our management in arid lands, this is not that high. And we need to quantify it and reflect, particularly when bovine animals is not the only one on which we depend. We have also small animals, and therefore your effort, your interest in sheep and goat is of very specific concern and interest to us. I hope your implementation plan would be taken seriously, and we do hope that whatever information is available elsewhere will be taken note of, especially for bovine animals, which are causing more of methane emission. Maybe we can have one or two questions, because you have concluded much earlier than anticipated. If there is any question, one or two, or clarification, we would be happy to have that.
Yeah, can I just make a comment, Professor Paruda? I think Professor Paruda is coming from Rajasthan. Rajasthan is part of arid areas. I mean, he was heading the agricultural research in India, and looking to the future, I think the introduction of new breed or trying to modify the genetic makeup of the existing breed is very important. And of course, there is effort is happening in India. There's effort which was led by Dr. Abul Naga, who was the president of the International Goat Association. And then he was heading all this organization. But we want to bring this down to the issue which we are discussing. And I thank Dr. Paruda for emphasizing the existence of a strategy and the implementation of it. And I think sharing the information with India, and India taking the information from there will be very helpful. This interaction is what is needed to face the climate change. Thank you.
Can I comment, Mr. Chairman? I think you review our work already. We will do this work in collaboration with Jakarta, and you was reviewing our work, and we after even our reviewing, we implemented with the breeders for 6 years, so it was very successful result. The other thing I would like to the small ruminant which you mentioned, I hope we wouldn't forget the buffalo. I'm a small ruminant by heart, but the buffalo is very close also to my heart and is a very important animal and very potential animal, and it been ignored or not ignored. They wanted to get rid of it. I don't know how, but that is the general policy which is dominating now in the country, which I hope they will change it. The Academy helped us in publishing some sort of book on buffalo, Egyptian buffalo, its potentiality and the challenging. I hope this will change the overall view of some of the people that the buffalo is not that producer, is not high producer, is not that adapted. It lived there for thousands of years with a very good potentiality of production and adaptation. So let us respect our local resources of the livestock and give it the chance to prove itself. Thank you.
I think a very good point, and I must again emphasize that there is definite need for partnership at regional level, and particularly in the livestock sector, where we can learn more. And we have germplasm, which is highly tolerant to high stress, especially the heat, and also to lack of fodder resources. And these animals are still surviving, so we can learn from each other. There could be collaboration for research between different countries in the Siwana region with that of South Asia and Central Asia. This could be one of the recommendations. Thank you, Dr. Abunaga.
Thank you.
We appreciate your efforts, which are very encouraging.
Thank you.
With this, we now move to the next presentation. Next presentation is by Dr. Professor Dr. Mahmood F. Usman. And Mahmood F. Usman is Emeritus Professor, again Animal Scientist, Animal Production Department, Faculty of Agriculture at Ain Shams University, Cairo. He has a PhD in fish nutrition, so he's a fish specialist, which is again encouraging. He has served on aquaculture as consultant for the Ministry of Agriculture, also a chairman of the General Authority for Fish Resources in Egypt, and he was a member of the Board of Trustees of International Center for Fish, World Fish, which also has a major regional center in Egypt. So we would like to hear from you the next presentation, which is on effect of climate change on fisheries and aquaculture.
Thank you, Mr. Chairman. I would like, first of all, thank you to allow me to have this short speech about the effect of climate change on the aquaculture and fisheries sector in Egypt and in the world. Always, when we talk about the climate changes, it has a negative effect in our opinion. But let me tell you something positive, that it will improve some of the aquaculture activities in the world. As you may know, that billions of people around the world depend on fisheries, on aquaculture, as the main source of food, essential nutrients, and livelihood. However, the fishery sectors is already exposed to significant negative impacts resulting from, it's not the climate changes, but due to pollution, which is caused by human being, deteriorated aquatic environments, overfishing, harmful practices, weather changes, which has some related to the environmental impact, increase acidity of the ocean and seas. Let me show you the difference between fisheries and aquaculture. Why we use always these two titles to show that what we are, what we have actually in the world, it's not coming from the ocean, it's not only coming from the seas, but it is mainly coming from aquaculture. As you see here, the improvement of both sectors, aquaculture and capture fishes, since 2000 up till 2018, it's constant for the fisheries in the worldwide, did not exceed 90 million ton since 20 years. But compared to aquaculture, it has been improved from 40 million, now it's more than 100 million ton. And we are expecting, according to the FAO prediction, that in 2030, we will depend mainly on aquaculture as a source of fish to the mankind. Why aquaculture? The demand for fish is constantly increasing with the improvement of the local economic situation. Previously, we heard that people get monthly, one per month meal of fish, but now we hear that they get weekly fish diet, because it's healthy, it's more healthy, better than other types of meat or animal protein. It has omega-3 fatty acids, which is very healthy, good for the cardio effect. Whereas aquaculture in Egypt and the world is only available method and effective solution to reduce the gap between fish production and demand. In Egypt, since 1980, where we started to think of producing fish through aquaculture, we were producing in that time only 18 or 19,000 tons of fish from aquaculture, and in the same time we were producing about 200 tons of fisheries. Nowadays, in 2020, from aquaculture we are producing more than 1.6 million ton fish from aquaculture and only 400,000 ton from fisheries. As you see also here, fisheries are constant since 2001. It doesn't change. In Egypt, we depend mainly on aquaculture. 80% of our production is coming from aquaculture, and 20% coming from the other sources which would be affected directly by the climate change. Mediterranean, Red Sea, lakes, River Nile, all these are producing 20% of our consumption fishes. The main fish species, what we are producing here in Egypt, we are number 1 in Africa. We are producing more than 86% of the total aquaculture production of Africa. We are number 3 in the world after China and Indonesia for producing tilapia. We are number 1 in the world according to the FAO statistics. We are number 1 in millet, el buri, in the world. Coming after that, carp, which is the first international aquaculture species worldwide. Effects of water temperature on fish distribution. This is the beginning of why we are afraid from the change of the temperature of the climate. As temperature increase, the productivity of ecosystems is likely to decrease in most tropical and subtropical oceans. By increasing the temperature, some of fish will migrate from the tropical area to the area where the temperature is very good for it. Because as we know that fish is cold blood animals. They cannot arrange their temperature. They get the temperature from the environment around it. With different water temperature, its content of algae, the water, will vary, which will reflect on the life of the fish that live in these areas. I can tell you a short story about the changes of the Mediterranean when we have had the high dam. It stopped the fresh water to be with a big amount in the Mediterranean. The Mediterranean lost 9 million tons because the water which was coming to the Mediterranean was to give the phytoplankton and zooplankton a good area to grow. To this area comes the sardine, and follow sardine, the fishes which eats sardine coming through Jabal Tariq. And it was at that time we were producing, the 22 countries were producing 10 million ton of fishes. Last statistics of the FAO tell us that it's only 1.3 million ton. These changes in water temperature will in turn lead to physiological changes: growth rate, development, reproduction and reproduction areas, disease susceptibility, predation, ecosystem changes, and its reflection on the life and migration of fish. Increasing salinity of water of the northern lakes as a result of the increase in temperature will affect the migration of the fry of mullet family from the sea to the meeting areas, fresh water, and therefore less fish stock in the lakes. Increasing the salinity of the water of the northern lakes as a result of increasing in temperature, which leads to an increase in the evaporation rate, as well as an increase in the pollution year after year as a result of industrial and agricultural drainage, and the lack of fresh water entering the lakes. Increasing in the degree of salinity stop the migration of the fry from the sea to the lake. Many inland fisheries are threatened by changing in water regimes, which in extreme cases lead to the disappearance of entire lakes and waterways. Climate change has direct effect through the decreased precipitation and increased evaporation, and indirect effect when more water is used for irrigation to cover the reduction of rainfall. The diagram shows you the effect of temperature and the changes of the climate would affect directly on fish, where it will have an effect on the suitability of the species for particular areas. As we know that there is warm water fish and cold water fish. Warm water fish like tilapia, carp, salmon. No, sorry, salmon is cold water fish. It lives in a temperature between 5 to 15 grade Celsius. These areas, would the temperature increase, then it means that we will have a new area for the warm water fish to live in. It will affect other factors such as oxygen levels. There is a contradiction relation between oxygen, dissolved oxygen and water temperature, toxic algae blooms, and the spread of pests, disease, and predators. In temperate regions, increased temperature can bring the advantages of faster growth rate and longer growing season. This will be a good thing for aquaculture fishes, because we will have longer growing period. Normally we start growing tilapia here in Egypt on April, ended by September. If the temperature increase, it means the time we can start actually in March, not in April, and we can go up to December. That means we can get more or bigger fishes. If higher temperature increase, the metabolic rates of fish more than food supply, and there will be a negative impact on growth performance. A decrease in sea ice cover could expand the area available for cultivating valuable marine species, providing new opportunities for areas that were previously unsuitable of raising for such activities. The negative effect of raising sea temperature include low water quality and increased risk of disease and an increased risk of toxic algae blooms that may destroy the stock or render it to be unmarketable. As you see in the picture, this is what we call algae bloom. The algae, due to higher temperature, reproductive that much, which not be allowed to fish to get oxygen, and this will be the situation if we don't enter and change the quality of water. Fisheries affect the global greenhouse gases emission through fuel inefficient fishing methods. Yes, I do. Emission associated with the trade of products around the world, including air and sea freight. But in aquaculture, the carbon footprint is lower than that other farm-raised protein activities, such as livestock. Whereas tilapia, carp, and bivalve molluscus produces 1.7 0.8 and 0.01 kilogram of CO2 per kilogram of life weight. There's some suggestion to counter the impact of climate change. General adaptation strategy must be made on the basis of ecosystem conservation, which is defined as a comprehensive and integrated approach to understanding and predicting environmental changes, assessing the types of consequence, and developing an appropriate response to their management. The tendency of acclimatized saltwater fish to low, medium salinity, this is one of the suggestions. Finding alternatives to freshwater fish for farming in brackish water. Work to provide alternatives to fish meal in the diet as a source of protein in fish diet. Establishment of marine hatcheries for spawning marine fishes. Implementing of marine fish farming projects to compensate for the shortage that may occur in freshwater fish. A distance of 200 meters. This is actually one of the things which has been اتعدلت in the law. Reduce the discharge various pollution into the lakes, making mathematical models to study the relationship between air temperature, water temperature in far ponds and water depths, conducting research related to work, to knowing the rate of increase in the salinity of the groundwater, the delta, and the salinity of wastewater. I would like
Thank you very much.
to thank you
very
for
much.
your kind attention.
Thank you.
We appreciate, we do appreciate your emphasizing the importance, and we are also happy to note that there will be less adverse impact on fishery sector as far as climate change is concerned. We now have the next presentation.
Professor Elbaz is with us, Professor Paruda. Professor Elbaz is on the screen now. He managed to get from Boston, and we are getting up very early. And if we can let him first, and then we continue. Thank you.
Well, we are very happy to have you, Professor Baj. We waited for you in the beginning, but it seems you could not join us.
Yes.
But I did introduce you in your absence about all your accomplishments and your leadership at Boston for so many years. So would not like to take long, but would probably give you the floor to talk to us on use of satellite image data in monitoring and assisting food production in arid regions. And since time is short, so we'll request you to help us in completing your presentation in 15 minutes.
Thank you very much. I'm sorry I was a little bit late, but I'm glad I made it. And I would like to speak today on the largest desert belt in the world, which includes all of the Arab world, from Morocco all the way to Oman. This is a very large dry area. That area is, and I'll try to get the images to see whether we can do that or not. At any rate, one of the most significant aspects of that desert belt is the fact that it includes the largest area that receives the largest amount of solar radiation. And that is measured by the amount of drying. The dryness measure of all of the North Africa and the Arabian Peninsula is very much larger than in amount than the deserts in Asia and North America. For example, the dryness measure of the Western Desert in Egypt and the eastern part of Libya is measured as 200. And the same dryness effect in the driest place in North America, which is called Death Valley in California, 7. So you can see how dry is that dry area in North Africa. The desert region, that dry desert region begins from the Nile Valley westward. And we know for certain that this area has actually been hosted by humans for a very long period of time, until about 6,000 years ago. So there were remains of human beings living in that zone for 6,000 years. We see grain, we see ostrich eggshells, we see hand axes, we see all kinds of things that prove that human beings lived in that place before it became that dry. So dryness came in steps until it became very dry about 6,000 years ago, where all humans had to evacuate and most likely had to go to the Nile River in Egypt and Sudan. We also see actually artwork, descriptions of the environment, the way it used to be from whatever left the art on the rocks and in caves, so that we know for certain that human beings were there because it used to get some more rain than it is than today. And that rain started getting less and less and less until it ended completely and totally about 6,000 years ago, where humans had to evacuate because of the incredible dryness. Because of all of this, we know for certain that since it used to rain for certain earlier than 6,000 years ago, there must have been some remains of that rainwater somewhere. And that somewhere would be in the rocks beneath the surface that have enough of porosity to acquire, to keep these rocks. Meaning that if it rained on the surface of the earth, then the water would descend into the porous material of the rocks and would stay there. So that if we know areas that used to host lakes, for instance, then there would be water that would have gone through the subsurface rock, particularly if it is porous like sandstone and some limestone, and that water would be stored in that rock for us to use today as groundwater. And that is an important item because now we actually begin to look at potential groundwater sites using satellite images. Because, although what satellite images would do, that we cannot see water beneath the surface. However, we can see the landforms that would have led the water to certain areas, and if the rock in these certain areas is porous, or in the past it would have water would have accumulated in the porosity of the rock, and therefore it would be there right now as groundwater. And we have tried that in North Africa, we've tried it in Northwest India, we've tried it in China, in all kinds of places where the idea was proven for certain. And we tried it in very dry areas like in northwestern Sudan, in Darfur area, and all places that had very little water, but had some water in the past. And we learned about that water in the past through the landforms on the surface that we photographed with satellite images, the remains of it, or the proof of there was such lake. I'm sorry, I cannot show you the slides for some reason, but indeed, in desert areas, we can look for the passageways of water in the past, and therefore figure out where the water was led from higher places, like mountainous areas, where it rained a lot, to downhill until it accumulated in flat areas, meaning deserts, and therefore in very arid areas, we may have the remains of that water that used to rain in the past, and it would have be accumulated in the form of groundwater. So I really think that satellite images and figuring out the kind of terrain that used to be, the shape of the terrain that used to be, and then figuring out where water would have accumulated, then with some instruments like geophysical surveys, we can figure out places where water might still be and use it as potential for groundwater exploration. We did that in Egypt very well, and whereby we have mountainous areas in southwest Egypt, near the border between Egypt, Libya, and Sudan, or the Gilf Kibir Plateau and the Huwainat Mountain, where it used to rain a great deal, and we saw all kinds of passageways of water on the surface that are now, they look now like dry valleys, like the dry valleys in any desert in the world, that led eastward. And that leading eastward, we thought that it would go to the lowest places in that region. And we figured out where would that region be. And we suggested to the Egyptian government, Dr. Abdul Biltagi was deputy minister at the time, and indeed the minister finally agreed to drill some wells, and they drilled wells and they found water beginning at 25 meters beneath the surface. And right now it is called East Huwainat region, where nearly 1/2 of the grain produced in Egypt now comes from East Huwainat, meaning 1/2 of the grain consumed in Egypt is now produced from that one locality, meaning that there is a great deal of water, and that water can supply all kinds of places for food production, meaning that indeed satellite image studies looking at the terrain in desert areas the way it is now, and figuring out the terrain the way it used to be, so we can figure out where water would have accumulated on the surface, and therefore where water would seep through from the surface to down beneath the surface, and therefore it would accumulate as groundwater. So the story is satellite image studies, figuring out the way the terrain used to be in the geological past, and figuring out where would water be today can very much help the production of water in dry areas where the dry areas that need both the groundwater as well as the water for agriculture the most. Meaning that the dry areas in the world need that most, and the dry areas in the world actually would provide the potential for the best possible application of satellite images in trying to look for groundwater the way it is today by studying the surface effects of the rainwater in the past. Thank you very much. That's the story.
We cannot hear you, Professor Raj Paruda. You are mute somehow. We don't hear you.
My apology. Thank you, Professor Alba. It's very impressive and comprehensive presentation in a very short time. Maybe we have a few minutes for any clarification, if you agree.
Sure.
One or two questions. Maybe Dr. El Beltaji would start.
Yes, I think it's a pleasure to have Professor Baz with us today. But the question really which we need to answer is how we can monitor the shift of the agroecology in the world. This is our concern احنا فلاحين as peasants and people who live in the dry area. The shift is dynamic because every half centimeter, every half degree centigrade will make a shift. The shift is happening all the time because this means in agriculture we have to change and shift our cropping system all the time. For us, this agroecological zoning is very important. And therefore, how can we use the satellites more effectively? I know that NASA is producing in the last 3 years 3 models, which one of them is out, to monitor much more precisely not only the surface temperature, but with big quality, which will give you an assessment of the changes happening on the temperature on the ground as well in the canopy. And this is where any peasant know what to plant out of these shifts, which is happening. How far this can be utilized in the future, how cheap is the technology for the developing countries to take this or to have access to the big data, which an organization like NASA, which you have worked with for years, can provide. Thank you.
Thank you very much, Dr. Adel. This is a very good point. And the measuring of the temperature of the surface of the earth and changes therefore in this temperature of the soil and of the rocks and all of that has not been an important item in NASA's mind. So that very little research has gone this way. And because of the point that you made now, I really think that it should be something that all of the developing countries can join together and ask NASA or ask space agencies in China and in India and in other places to try to concentrate on that, in Europe too. Because nobody in the satellite image business has ever really thought about that in great detail and thought of how do we measure that. But I'm sure it is possible that measuring the temperature from space should be very easy, and the changes therefore should be very easy if we have the proper satellite instruments to do that. So maybe we need one satellite the temperature satellite to measure the temperature of the soil, of the earth around all agricultural areas and tell us about what the changes have occurred. Since it's not there, then there should be a scientific movement to try to get space agencies, NASA and the Russian and the European Union and maybe countries like India, and where they had done very well in looking at satellite images in general, to figure out how do we have one satellite to look at all the changes, the tiny changes in the temperature over agricultural area, over places where that produce the food that we need. So I really think it is a doable thing. It is not available now, but it is doable, definitely. And we need to make noise to say that we need that. May space agencies work on this, because it is a very important thing for food production and therefore for the benefit of humans worldwide, and particularly in dry areas. So I think it is doable, and it's not being done, and it can be done if we voice enough, if our voices are high enough.
Thank you.
Okay, well, thank you, Professor Farooq Albaz. We appreciate your joining us.
Thank you.
And maybe there could be some recommendation on water management in dryland areas.
Yep.
And I think you could help us in framing that.
Sure.
Just one paragraph in terms of what could be the strategy on water management in dryland areas, because this is the most critical issue. And it is water tables are going down, more overexploitation taking place, less of rainfall we are experiencing. So how to have, in fact, proper water management, and there is edaphic pressure. So all these things would demand a comprehensive strategy on water management in dryland areas as a recommendation from our discussion.
Indeed, thank you very much. I'll be glad to discuss with you anyhow.
With this, we are told that Dr. Toshichika Lijumi is with us now online. So maybe we give floor to him. I have already introduced you, Dr. Lijumi, earlier. So we'll save time, and we will have 10 minutes for your presentation, please.
Okay, first of all, my apologies for I couldn't attend from the beginning. And thank you very much for chairman and organizer to give me the opportunity to present. So let me share my screen. Yes. Okay, probably 10 minutes. So this talk is based on recent publications in Nature Food, and which is an outcome from joint research between Agricultural Research Corporation in Sudan and Ritland Research Center, Tottori, Japan. Climate change likely contribute to observed stagnation of yield growth. As you can see, the wheat yield growth has been slowed down since the 1990s, of which annual rate is 1.7% per year, which is below half of the earlier years. The accumulated evidence shows that warming has already affected wheat yield negatively. Field experimental data shows that wheat yield decrease as season mean temperature increase, and the crop model also corroborates this tendency. A different global assessment shows that climate change during the past 33 decades negatively affected wheat yield in low latitude in red, while it positively affected wheat yield in higher latitude in green. The world hottest wheat growing environment occurs Sudan, except its northern part. This environment is classified as the wheat mega environment number 5, defined by the summit, which is characterized by irrigated condition with coolest cooler mean temperature is greater than 11 degree and below 60 degree. Anyway, characterized by high room temperature. So the question addressed in this study is that the wheat yield have increased for the past and need to continue to increase to meet increasing wheat demand in Sudan. The wheat demand in Sudan is anticipated to triple by 2050. But climate change would stagnate yield growth compared to what would occur without warming. So the question is, at what rate do new heat-tolerant variety need to be bred to offset the negative yield impact from warming? To address these questions, we used a process-based crop model called SIGMA. Although I didn't go into detail here, but the details of the modeling are available in recent publications. We calculated wheat genetic coefficient within the model for each variety grown in Sudan using field experimental data. The coefficient, modified coefficient includes crop thermal requirement from sowing to harvesting, the response of RAI to heat stress, and so on. The irrigated frequency was set to be consistent with the local management to simulate soil water adequately. So the calibrated model will reproduce the observed response of development and yield to season temperatures. The left panel is for observations and right panel is for a model. Different color indicates different varieties. Blue indicates a recent variety Imam released in 2000. And pink indicates earlier variety called Debater, released in 1982. So as you can see that the imam have a higher yields than the beta, especially in the high temperature conditions. This observed tendency is well captured by the model. Then we input future climate projections to the model. The projected warming in the middle of this century relative to the pre-industrial level range from 1.5 warming to 4.2 degree Celsius, depending on the greenhouse gas emission scenario and climate model. We sought the best sowing rate that gave the lowest season temperature and derived yield response to temperature for each variety and each location, 3 locations in the Sudan. The benefit of adopting the relatively heat-tolerant variety in blue is clearly seen for Wad Medani and New Harfar, central and eastern part of Sudan. But the benefit is unclear for Dongra, located in the northern part of Sudan, because of relatively low season temperature than the other 2 locations. Using the established temperature yield relationships, we derived yield change per 1 degree warmings for each warming scenario and for each varieties. In the high warming scenarios, yield change per 1 degree warming is minus 51% per 1 degree warmings. The warming rate can be calculated from the temperature projections, in that case 0.052 degree per year. By multiplying these values, we can calculate the required annual rate of yield increasing to maintain current yield level in the warming climate. That is 2.7% per year. In the low warming scenarios, the required annual rate is 0.3% per year. This result indicates that by 2050, yield of new heat-tolerant variety need to increase 0.2 to 2.7% every year relative to current average yield to offset the yield reduction associated with projected warming. So let me summarize key findings of this study. Current varieties tested here are insufficient to offset the adverse effect of projected warmings by 2050. Varieties more tolerant to heat need to be bred and disseminated. If high warming scenario was assumed, the required development rate of new variety is estimated to 2.7% per year, which is unrealistically high compared to the recent actual growth rate of 1.7% per year in the earlier slide. The required rates can be reduced to a more feasible level of 0.3% per year if warming was limited to 1.5 degrees. This result together indicates that climate mitigation is necessary in parallel with adaptation to ensure that the development of adaptation measures does not exceed our capacity. So more detail are available in the literatures if you like. Thank you for listening.
Well, thank you very much. We appreciate your very interesting presentation in terms of impact of temperature on yield of varieties, which is especially in the situation of Sudan, and we need to be more attentive and breed varieties that are more resistant to high temperature. This is what was highlighted in some earlier presentations. And your recommendation also supports that. Thank you very much.